All right, so we got about a minute and a half. If you have any questions, you can go ahead and ask either using the voice channel or the text channel. The YouTube side has started already, so if anyone wants to watch this, on the YouTube side, that's good too. And I'm just gonna wait another minute or so before we get started with today's class. So today is going to be mostly on quantifiers, and then we'll get back to notations, in set notations, but this time we'll use quantifiers to help us um, specify set notations. So that's what we'll do today. There will be a homework assigned at the end of today. It's just your basic set theory. This one does not use quantifiers. So I could have assigned it last time, and which was a week ago, because on Wednesday my power was out for 14 hours. And I got cell phone connection, and even that was sporadic during that time. All right, so we got about 10 more seconds, and then we'll go ahead and get started. So remember, if you want to use text participation, please use the channel, the text channel in Discord that has today's date on it. So that's kind of how we do things. All right. So I'm gonna get started here. All right. So we got a few things to talk about. The first one is what we're going to do today. We'll talk about quantifiers, and I think I might try to use a use a program to kind of illustrate what it means to use quantifiers. So I might go that route. We'll also have a role taking activity here, and I'm getting some squeals. Not sure where it's coming from. Not sure. Doesn't look like it's coming from anyone's mic. Alright. Alright. So let's go ahead and get started. There we go again. That's squeal, which I don't think is coming from a feedback, because I'll keep an eye on it. Because I was recording something earlier today and there was no squealing like that. Alright, so we'll get started with basic quantifiers. So this is the slide that we're going to start with today. And it has not been refreshed. So what I'll do is I'm going to refresh it so that anyone who is interested can figure out how to get the notations to work. So that's the only reason why I'm refreshing this. So I'm doing this on the side. And when it's updated, I can update the web page. There we go. So it should be updated now. And it just looks very slightly different because it's rendered by a slightly different tool. But if I right click on a formula, alrighty. Okay, Jay, you might want to turn off your mic. Alright. So if you right click on a formula and you say show math as, then you can go to tech command and it will show you the exact command in tech, TEX. It looks like TEX, but it's really not. Okay, it's actually tau epsilon chi, which are Greek letters. So basically, this is how you can learn how to use LaTeX. And I heard that Canvas, was actually having an issue with its equation editor, the one that's built into the HTML editor, because there was a meeting last week, with Education Technology Committee, which is a district-wide committee, and they talked about, how Structure, which is the publisher of Canvas, is attempting to fix that problem. So anyway, we'll go ahead and get started here. So quantifiers implicitly apply to everything or nothing in the universe. To make our discussion more concise, we'll use variable x to refer to a thing that we are examining. And then p of x is some kind of Boolean function applied to x. So p of x is also known as a predicate. I think we have used this term before. So what a predicate is it really is a function that just returns a Boolean value. So you can give it an x to evaluate, and it will come back as either true or false. So now, if we use this notation here, this is an inverted A, which stands for all. So this basically is saying for all x, p of x is true. Okay, that's kind of what it's implying. So you look at this expression. It's not by itself. It is not always an assertion. In other words, it's not saying that for every x, p of x is true. Okay, it is more like a question of is it true or is it false that for all x, p of x is true. It's kind of a question. Okay, so this expression itself is Boolean, and it can be either true or false. So I'm just taking a quick look at the text channel and make sure that nobody has a question. So the other way to use for all, the other word that we can use for all is every. So the word that we use in every day, okay, no pun intended, the word every is the same as for all. Okay, and then the other one, the other quantifier, this is called the universal quantifier. Okay, the universal quantifier means everything has the following property. So the other one is called the existential quantifier, which is there exist. So the way you type this in LaTeX is exists, backslash, and then exists, and that will give you the kind of like a mirror image of an E. But this time it's horizontally flipped instead of the other one, which is vertically flipped. So this is basically saying there exists an x such that p of x is true. But once again, it is not an assertion by itself. It can be just it can be a question. Okay, is it true or is it false that there exists an x such that p of x is true? All right, so let's move on. Note that the important thing of saying at least one, okay, because there exist is also saying there exists at least one. You can also say some. Okay, so if you want to replace there exists with a simple word that we use in English, that word would be some. Okay, there's some x such that p of x is true. So do we have any questions? I'm gonna pause a little bit here and see if anyone has a question. So I'll be looking at the text channel at this point. All right. Doesn't seem to be the case. Doesn't seem like anyone has a question. And then from time to time, I kind of need to, I need to check to make sure that the Discord session is still going, because sometimes the Discord would crash without any visible sign. So I'll be talking and assuming nobody has a question when no one could, pose a question, or I cannot see the questions. All right. So if there are no questions, we're going to move on to section 3. So section 3 talks about the more complex use of quantifiers, and this time we're trying to combine the use of quantifier with negation. So let's take a look at this expression here. This expression is saying, is it true or is it false that it is not the case that there's at least one x such that p of x is true. So let me say that one more time. This is saying, is it true or is it false that it is not the case that there is at least one x such that p of x is true. So this expression here, there's a way for us to move the negation to the so that the negation applies directly to the predicate. But to do that, we have to change the quantifier. So you can see how there exists quantifier becomes the for all, and then the negation goes from the outside to the inside. So the second one, if we were to say it in English, it is the same thing as saying for every x, okay, for every x, it is not the case that p of x is true. So now you have to ask the question, do you think these two really are saying the same thing? The first one is saying it is not the case that there exists at least one x such that p of x is true. The second one is saying for every x, p of x is not true. So are you sufficiently convinced that these two statements are saying exactly the same thing? So I'm gonna pause here a little bit, just to let you guys digest this a little bit. If you have any questions, now would be a good time to ask. All right, I'm not seeing any questions, so I'm going to assume that we can move forward. So the other way around is kind of similar. So this time we are starting with a different statement. So this statement is saying it is not the case that for every x, p of x is true. That's what we start with. But are you convinced that this is also saying exactly the same thing? Okay, the alternate form is saying that there exists at least one x such that p of x is not true. Okay, so do you think this statement is the same as this statement over here? I'm not seeing any questions, so I am going to assume that we are good here. Okay. Alright, so I'm gonna check a message really quick because I got a ping from my Discord, my Canvas box here. So I'm gonna make sure. I just wanted. Okay, that's not related to the lecture, but it is something that I need to kind of talk about, so I will get back to that point. Alright, so now we need to think about what x are we talking about. Okay, so p of x is pretty easy. Okay, p of x is x even. Okay, p of x can be is x a professor. Okay, p of x can be is x older than 65 or not. Okay, basically it's just a Boolean function. But then if p of x is asking is x is even, then what about x itself? What are we applying the predicate to? When we say for all x, okay, what are we saying? Are we talking about all the integers? Are we talking about all the real numbers? Are we talking about all of the irrational numbers? Are we talking about all of the complex numbers? Or do we also include people? Do we also include animals? Do we also include all the atoms in the entire universe? Well, the answer is, if we use just this notation for all x, this x, in order to bind this x to be evaluated by p, it actually binds to everything in the entire universe, abstract or otherwise. So it doesn't seem to make sense, right? Because what things exist in this universe? People, okay? So you can basically say, is tag even? That doesn't seem to make sense. Now, if you ask is tag odd, you can sort of say yes, tag is kind of odd, okay? But even is not a concept that applies to people, right? It only applies to integers. Even for numbers, okay, you cannot even say, it doesn't seem to make sense to ask whether 2.5 is even or not, or to apply that to a complex number, right? Because a complex number has two components. So when you ask whether a complex number is even or not, are you talking about at least one of the two components is even, or are you requiring both components to be even for a complex number to be even? It's not well defined. So that means, in order to use the um, especially the universal quantifier, we kind of need a filter, okay, to basically say no, 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 we are not applying, we are not applying p of x to people, we are not applying p of x to cars, we are not applying p of x to things that are whether it is even or not does not apply. Okay, so that's what section 4 is talking about. Section 4 talks about, we need some kind of a filter, okay, because the quantify itself applies to everything in the universe. So it is the expression inside, the expression that we can say, if something is not a number, don't even it's not an integer, don't even bother to ask whether it is even or not. Okay, so this is a very common thing that people need to do in order to use quantifiers. So now we want to look at this expression here, where the mouse pointer is. And this particular quantifier is asking, is it true or is it false? That for everything in the entire universe, okay, we'll call that thing E. The one thing that we are examining is called E. And the first thing we evaluate is not even P of E. The first thing we evaluate is whether E is an element of a set X or not. Okay, if it is, okay, the implication says if it is, okay, if the precedent of an implication is true, or if the left hand side of an implication is true, then the right hand side can determine whether the implication itself is true or not. But on the other hand, if E is not an element of X, then the entire implication is true to begin with. Alright? Alright, so this is a bit, to digest. Let me see if you guys have any questions. If not, then I'll go ahead and see if I can use an example, written in C to sort of illustrate the concept, but not. We'll see how that goes. But first of all, I want to see if you guys have any questions. Is E an if statement? E itself is not. This whole thing is a conditional statement. Well, okay, it's not an if statement, it is a conditional expression. So you have to remember what is the meaning of the operator implication. It's the same thing as the negation of the left hand side or the right hand side. So does that kind of answer your question, Angel? All right, excellent. Okay. Any other questions? Because I want you guys to kind of think about this, and if you have any questions before I even present the example, I think it's a good idea to talk about those questions first. Okay, I'm not seeing any questions. All right. So if there are no questions, I am going to write a program which may make certain things more confusing because in a C program I cannot use the concept of a set. Okay, so the first thing is I want to define P of X. Okay, P of X, which is a predicate, returns a Boolean. But in C, not in C++, this is plain old C. There's no such type as a bool. So that means the closest thing I can get is just an integer. So I'm going to say int here. And we'll say P of X. So X in this case can be anything. Okay, so we'll say but in C you cannot have a parameter that can be any type because this is a compiled strongly typed language. So I cannot just say, hey, X is just a parameter. We'll evaluate what X is inside the function. That's no way to do it. Audio just cut out. Is it true for everybody else? Okay, let me just type. Oh. Alright, Aiden. Let's see if Aiden can fix the problem. Oh, reconnected. Okay, that's good. Excellent. Okay, so getting back to the example here. So I can just say, whether x is even or not, and the way to quickly do that is to say there are many ways to do it. Okay, we'll use the most obvious way to do it, which is x mod 2. If x mod 2 equals to 0, then x is even. Okay, so that's what the predicate is. And now what we do is we want to use an array, sort of like a set. Okay, so we'll use an array as a set. It is not a very precise way to do it, because a set is definitely not an array. But in the absence of being able to represent a set natively, we'll just go ahead and use an array for that purpose. So the array is things. Okay, so things is an array, and we'll give it some values. So we'll say 3, 2, -1, 5, 10, -7, 9, and 2 is already here, but -2 is not. Okay, so this is how I define the array, okay, of things. So now I want to define the for all and also there exist. Okay, so now the for all by itself returns a boolean. It returns either true or false. So that is it returns an int because it's a C program, where there's no actual boolean type. But what do we need to pass to for all? Okay, that's the next question. The first one may be a little foreign to most of you, is we need to pass a pointer to a function, because we need to pass p as a quote unquote variable. Okay, because we don't want the for all function to apply to only the function p all the time. So we want to be able to specify what predicate are we talking about, when we use the for all. Aiden is typing something. I'm gonna wait a little bit here. But does anyone have any experience specifying a pointer to a function? Yep, Aiden has gotten it correct. But I want to see if the rest of the class has any exposure to a pointer to a function in C. It's a very primitive concept, to basically be able to pass a function as a parameter to another function. But it works. Okay, it works for C programs. All right. So we'll say this is Q. Okay, so Q is a parameter, but it also takes int as its own parameter. So Q is a pointer to a function, and that function takes int as a parameter, and it also returns an int as a return value. Yeah, you can do a type def. I mean, that's kind of cool. I'm not a type def person. I like to make things kind of as spelled out as possible, especially for simple programs. So this way we don't have to look up things, right? So p itself is a parameter, but we also have to basically specify where's my universe. Okay, so the universe is going to be a pointer to an integer, because we can't really have in C and C++ and Java too, because they are strongly typed languages. We can't really specify, hey, this parameter can be of any type, okay, or this is an array of any type. And then we need one more thing. Okay, we need to know how many things are in the universe. And the reason why we need that as a separate parameter is because in C and C++, when you're passing an array, you're passing the starting point of an array, but you're not passing the size of an array either. You're not passing the size of an array because it's not a part of what you're passing. So we need to pass the number of items in an array as a separate parameter, which is really kind of lame, because in most other languages, especially in scripting languages, the length of an array or the size of an array, depending on the language, is a part of the array. You can always access that, okay, as a part of the array. But C and C++, especially C, has a very efficient way of doing things, and sometimes it doesn't give us the convenience, okay, to do stuff like this. All right, but that's not the most important part. Okay, so we'll copy and paste this because the template for exists is about the same. So we'll say exists. Okay, there we go. All right. Now we need to fill in the content. So typically the way I do things is I use a local variable, in this case I'll call it result, to keep track of what I'm supposed to return, and then at the end of the function I just return result. Obviously there's a whole lot of stuff that I need to do with result, such as initialization and stuff like that. And then the same thing with exists. Okay. So we'll copy and paste a little bit of stuff here. All right. All right. So now the question is, when we use for all, what are we going to return? Okay. So let's just say that we are not concerned about the filter, which is going to be another function that we have to add to this. But let's just say that we're not concerned about the filter. And we're only concerned about, does everything in this universe, okay, which is really just an array, is the predicate pointed to by q returns true for everything in this particular universe. So that is what I want for all to compute. For all does return a Boolean. Yes, okay. In C, it is it's either 0, which is false, or non-zero, which is true. So there's a whole lot of different ways to represent true, but there's only one way to represent false, which is 0. So that's kind of the standard of C. C++ has the same thing. Java does not. Okay, Java would need you to convert an integer into a Boolean explicitly, whereas C and C++ would just interpret everything that is non-zero as true, everything that is 0 to be false. And that 0 can be even a pointer. A null pointer is also considered false, which is kind of cool and confusing at the same time. All right, so in this case, okay, I just clicked the wrong key, and that's why the screen just hopped. Okay, so in this case, I want result to be non-zero. Okay, and you can always say non-zero like that, which is not 0. Okay, that's actually legitimate. A legitimate way to say result is true. And what is the difference between that in Q? Okay, if you guys refer to the text channel, Q is a pointer to a function, and that function takes int as a parameter, and it returns int as its own return type. The second one is just a pointer to an int. Okay, and in C and C++, there's no differentiation between a pointer to an integer versus an array of integers. And so the second question that Caden asked, are both pointers? The answer is yes, but they're pointers to entirely different things. Okay, all right. So we got 2 more people typing, 3 more. So I'm gonna wait a little bit until they're done, so I can finish my coffee too. All right, could Q return another type other than int? The answer is whatever the return type of the function that is pointed to by Q is, needs to match whatever I'm highlighting here, which currently is an int, okay? Because we just want it to be a Boolean, and remember in C there's no such thing as a Boolean type, so I'm using int in place of a Boolean type. But as a feature of the language, yes, you can change what I'm highlighting here to return something else. All right. Okay, so for those of you who want to learn more about this, this is called a pointer to a function in C. It is a very useful concept, in C, because C has, C++ has object-oriented programming, so it has got abstract functions and whatnot. And before that, C is not object-oriented, so we rely on pointers to functions to do a lot of things that we take for granted in object-oriented programming. All right, so now we'll go ahead and write a loop. Okay, so the loop is, I can make this a for loop. Okay, and depending on how complex we want to make this, there are a few ways to do this. Okay, so we'll write the for loop. Okay, and inside the for loop, we're going to specify the initialization. So result is already initialized, from the declaration itself. And now we have nothing else to initialize. So now we specify how do we stay in this loop. So if you just want it to be simplistic, okay, you can basically say we stay in the loop as long as n is not 0. Okay, so n all by itself can be the condition to stay in the loop. Okay, because n is the number of elements in the array. So as long as n is, so I'm planning on changing n per iteration in the post operation, but we can use n by itself, as a condition to stay in the loop, because we have at least one thing in the array that we have not considered yet. So now we have to specify the post operation in a for loop. So the post operation, there are two things that we have to do. One is decrement n. Okay, move the mouse pointer. So one is to decrement n. Basically, we're saying, okay, we are evaluating, another element, okay, in the array using q to evaluate it. Okay, and then I'm using a comma as a separator. This is the other operation that I need to perform. So the other operation that I need to perform is a little bit tricky. Okay, so I'm going to write it out first, and then we'll go ahead and basically find out what does it do. Okay, so we have result equals to result, and then and. Okay, ampersand ampersand is logical and then we have q. I believe the asterisk is actually optional. Okay, I could have just used q and then open paren, and then we want to look at the current element of the universe. Okay, that needs to be evaluated. So we have at universe, but we also need universe as a pointer to advance to the next thing. But we wanted to point to the next thing as a post operation. So that means we need a post increment like that. And to make this a little bit more clear, I'm going to use extra parentheses. I believe these parentheses are not even needed because of the default priority of operators. And that's it. Okay, this loop does not even have quote-unquote a body. Well, that's a very good question. Okay, so we got a question of what value does result, what value is result initialized to? Okay, that's a very interesting question. Yes, it is going to be a value other than 0, but we don't know which one. It can be -1, can be -3, can be 42. Okay, can be 666. Okay, can be whatever thing, okay, can be any one of the non-zero integer that we can store in the int type. That's all it guarantees. Okay, it just guarantees something that is non-zero. Okay, but I want to use this notation because I don't want to use a 1 or a -1, because there are so many different ways to represent true for an integer. I just say, hey, not false is the best way to say it is true. That's why I use exclamation point 0 in this case. All right, so we'll go ahead and check this out. Okay, this function is, I think it's fully written, and we'll go ahead and check whether it is what it's going to return. So we'll go ahead and say we'll have another int here, test. Okay, so we'll say test equals to calling for all. And then we use p, which is defined all the way up here. So you can use ampersand p, as the address of a function, but I believe, p by itself, may work too. So that's our predicate. And then the universe would be the array of things. And then now we need to specify how many items are in the universe, because we require that as another separate parameter n. A few things that we can improve on this function is I can also make a const here, because we are not going to change anything in the universe. So adding the const int basically means if I accidentally try to change a thing pointed to by universe, the compiler is going to bark at me and go like, hey, tag, you're not supposed to do that. And Aiden is correct. Okay, so we can use size of. Okay, so size of things would appear to be, hey, isn't this all we need already? Well, the answer is no, because size of returns the number of bytes. So it's going to tell us how many bytes the entire array things is going to take up, but we are not interested in the number of bytes. We want to know how many items we have in the array. So now, if you divide that by the size of each thing in things, then we are good. So Aiden is using int, so I'm going to use something else. This is what I'm going to use. So instead of using int, I'm going to use dereference things. So this way, if I choose to say, hey, things I need to use exactly 64-bit integers, I don't need to change this expression, because it is basically it's self-fixing. Because whatever things is pointing to has the type of the array. So that's kind of a interesting little trick here, so that the code is a little bit more portable. Yes, I can simultaneously write code that is difficult to read, but also portable at the same time. Yep, you can define that too. Array length, to be the size of a pointer divided by whatever that pointer is pointing to. Okay. When people ask questions, the reference of this, that is confusing. So which part is quote this end quote part? I kind of need to be more specific. Okay. Alright, so star q is basically saying whatever function q is pointing to. So we are actually calling the function that q is pointing to. And then this part here, okay, is basically the argument that we are passing to the function that q is pointing to. So this one here, I think you guys really should know this already if you have taken CISP440, because it really is just a combination of post increment and dereference. And the way to understand this is to go from the inside out. So you start with the innermost portion, which is universe. Universe is a pointer to an int or const int. Doesn't really matter whether it's const or not in this case. And then what we do is we do a post increment. So post increment means this thing as an expression is returning whatever universe has, but it has a side effect afterwards to actually quote unquote increment the pointer. But this time, because it's incrementing a pointer to an int, it's not just adding 1 to the pointer, it is actually incrementing by the size of an int. So we point to the next integer. Uh-oh, we got another one losing the audio. Is the rest of the class still hearing me okay? Okay, this is really odd. Maybe I should switch to Zoom at some point, just for the video. If you guys want to switch to Zoom on Wednesday, just let me know and we'll go ahead and switch to Zoom. Yeah, I kind of like Discord too, but I also want to make sure that people don't encounter problems, like losing the audio and stuff like that. Yeah, I think most people can hear me the entire time, but just having some people, getting the audio to drop out is not good. All right. Yeah, that's what I really like about Discord is the text messaging and just being able to do screenshots easily. I mean, using Zoom you can do it too. You just have to post your image on the website and then post the link to the website, but it's really a lot more steps. Okay, yeah, YouTube should be fine. YouTube is YouTube. Yep. Okay, so getting back to here. So this expression here is returning a pointer, which is just universe itself before the increment, and then we're going to dereference that pointer, which is whatever universe is currently pointing to. So yes, I kind of intentionally picked a cryptic way to do this, but I also do this because I want to make sure that you guys get a review of your C stuff. This is not even CISP440 stuff, not even close. This is actually CISP360 stuff, not even 400 stuff. Yeah, so I can really test whether people understand this C stuff or not just by writing code like this. Okay. All right, so let's go ahead and check this out. Okay, so the answer is it should be false, right? Because p of x is going to return true if and only if x is an even number. And then we are saying, is it true or is it false that for everything in our universe, this is the universe that we are talking about, that thing is an even number. And we can tell right away that no, not everything is an even number. Some are odd numbers. And as a result, the for all really should return false, which is a 0. In other words, by the time we get to line 38, the local variable test in main should be a 0. All right, so we'll give it a try. Okay, and also take a look at this program. There's not a single printf or cout in it. Okay, I typically write a lot of programs without cout or printf because it's not needed. Okay, to debug a program like this, I have the debugger. Okay, that's what the debugger is for. It is not what printf is for. Printf is not for debugging. So if you have been told, most likely, to use printf to debug a program, now it is time to learn how to use GDB. Okay, Aiden is saying, printf is the poor man's debugger. In the absence of any debugging tool, yes, I would use a printf just to see when I get to a certain point, and when I get to that certain point, what is the value inside a variable. But if I have a debugger, which is what online GDB is all about, I'm not going to use printf. Okay, so it's a last resort kind of thing. All right, so we'll go ahead and debug the program. There we go. And I got some syntax errors. Okay, it complains about expected close param before semicolon. Okay, so I probably forgot something, and that's on line 19. This is the line. Alright, so what am I missing? Let's see here. Oh, I need one more to close the for. There we go. Alright, so now we're good. And this is a very odd looking for loop, isn't it? Okay, there's no actual body for the loop. Everything that I need to do is contained in the post operation. This is the post operation. And then the condition to stay in the loop is also deceptively simple, which is just n. So the idea is n is also serving as a counter. Okay, it is a countdown counter. In other words, it starts with the actual number of things in the universe, and then as I start to evaluate things in the universe, n gets decremented, so that eventually it gets down to 0. Then there's nothing else for me to evaluate in quote unquote that universe, and then we can get out. All right. So it's a tricky program. Okay, yes, I did, try to write this program in a weird way. And now we try to debug again. Looks like we are good this time, so we just run the code. Now we are on line 38, and we say print test. We don't even need to do that, right? Because all the local variables are on the right hand side. We can see the test is a 0. Very good. Okay, let's do it one more time. And it's good. Okay, so we got this code. It seems to be working. All right, so now it's time to do the exists, because I want to do the for all, and then we will do the exists. So this way you can compare and contrast the two. So for exists, the result is going to be, oh, okay, I gotta get out of the debugger first. So stop the whole thing, and then now we are back to editing mode. So we need to initialize result to false this time. Okay. So in order for exist to return a true, we have to find something. Okay, we have to find a reason, at least one reason, for result to be true. And then the other thing is, I'm going to maintain, for the most part, the structure of the for loop, which is really kind of weird. But this time, I'm going to change the and to an or. So we have a logical or, and the rest is exactly the same. In other words, with exists, okay, the default is false, and I'm looking for a reason to return a true. Okay, and that reason has to be this one here. Now, if I have multiple reasons to return true, hey, not a problem, okay, because this is a logical or, so that means if result is false, then, and this part returns a true, then the whole expression is going to be true. But if result is true to begin with, hey, no harm done, okay, it'll just be true for, from that point on. So now we'll go ahead and test again, and this time we'll test exists. Okay, so, oh, okay, we have to change this. There we go. All right. Now we debug the program again, and then just run the code to the breakpoint, and we can see the test is 1 this time. Now, as long as it is non-zero, we're good. Okay, so it can be -1, can be 16, can be -2000. It doesn't really matter. Okay, as long as it is non-zero, we're good. All right. So is this helping to illustrate, the concept of for all and exists? Okay, I'm not seeing any text messages, so I'm going to assume everything is good up to this point. All right. So now what we're going to do is to be able to specify a filter. In other words, we'll say, yeah, we want to see if everything, is meeting this requirement. But what I really mean is we'll check only certain things, okay? Not everything in the entire universe. So in order for that to happen, I will need a filter function. Oh, forgot to stop the thing again. All right, so we'll need a filter function here. So we'll say int f int x is a filter function. So the filter function is also returning just a Boolean. It's basically testing for a certain type of membership. Okay, so in this case, let's just say that we are only interested in non-negative integers. Okay, so as long as x is greater than or equal to 0, it is part of what we want to actually apply p to. Whether then we want to see if it's even or not. If x is negative, then we will say no, this is not applicable. Okay, we are only interested in the non-negative values. Okay, so the filter function now needs to be passed, as a function, as a parameter to for all. Okay, so same kind of thing. So this is, I'm going to use g. Okay, so now we just have one extra function, and same thing over here for exists. So g is our filter function. There we go. And now the question is, how does it apply to the rest here? Okay, so this time it is a little bit more complex, in terms of the pointer arithmetics, because I have to use the implication. Now, if you remember, there's no such thing as implication in C. There's no operator, there's no Boolean operator called implication, so we're going to have to invent our own. And because we want to stay with just regular C, so kind of the only way, well, not the only way, but the more obvious way to do this is to use a macro. So we'll say implies, okay, and it has two things. It got x and y in it. So implies is really the same thing as negating the x, okay, or y. Okay, that's basically how it works. Now, the reason why I have all of these extra parentheses here is because if implies is inside another thing, the extra parentheses will make sure that the macro expansion doesn't end up with some kind of weird interaction with the original expression here. All right, so we'll have to make some changes here because we need implies now. The left-hand side of the implication is the application of the function that G is pointing to, and then we have universe here, and I'm just looking at the parentheses. Now this plus plus is now kind of, I think it will still work like this because I think the plus plus means after, and that means after the entire expression is evaluated. So it's not gonna do the increment because there's no specific order. Okay, when we have a, let's see. Oh no, this is fine. This is fine because the logical OR operator does enforce that the left hand side is evaluated first, and then the right hand side. Oh, then we have a problem, don't we? Okay. How many people are seeing a problem here? The post increment can be an issue, and it has to do with the logical OR operator. Okay, I'm gonna let you guys think about this for a little bit, like 10 seconds, and then I'll give you the answer. It won't advance if not x is true because of short-circuited Boolean evaluation. That is correct. So Aiden has just pointed out the flaw of this logic here. Okay, because so let's take a look at the entire thing. Okay, so we're zooming in to just this expression here. So the macro expansion means this part here is gonna be x over here, and then the application of whatever function q is calling is pointing to is going to be the y over here. So the problem is this is an OR operation. It has got the left hand side, it has got the right hand side. Logical OR is guaranteed short-circuited in C, C++, Java, and most programming languages. It is also guaranteed as a result to evaluate from left to right. So x is going to be evaluated first, but if not x is true, which means if x is false, then it will not evaluate y. That is what it means when we have short-circuited Boolean evaluation. But if y is not evaluated, neither is the post increment. And if the post increment is not evaluated, then the pointer universe is not going to advance. So we will basically be stuck in an infinite loop in that case, because the next iteration coming around will be, okay, I take it back. It's not truly an infinite loop, but the pointer is not going to advance. N will be decremented. Okay, so N will keep decrementing because N, the decrementing of N is outside of this particular sub-expression, but the pointer is not going to advance, which is going to be a problem. So we cannot do the auto increment here, and instead we're going to have a comma here and then do the increment outside of the implies macro expansion. So plus plus universe is going to be out here. All right, so if you're not following 100% of what I was saying, like the short-circuited evaluation, or the plus plus operation, the post increment, why it is a post versus a pre-increment, or the priority of dereferencing versus post or pre-increment. That means well, maybe it's time to review some of the C concepts, because these are actually just plain C concepts. They are not super tricky stuff, okay, in higher level classes. All right, so it's a filter. We got the filter in, and then we also make sure that the pointer advancing is done correctly. So the next question is, what exactly is the role of a comma? Okay, we got one here, and we got one all the way over here. So now the question is, what exactly is a comma in this case? And because most people think about a comma and go like, well, it's something that we use to separate things, right? But so is a semicolon. So is this semicolon here. So the question now is, what exactly is a comma? In other words, what exactly is this entire thing over here? If you read the syntax of C, this entire thing, the part that I have highlighted, that is one expression. It is one single expression. So the only reason why this is considered one single expression is because the comma in this context is an operator. This comma is an operator, and as is this comma as an operator here. And when I'll bet you, when you took CISP440, your professor never mentioned that comma can be seen as an operator. Okay? Because when we think about an operator, okay, we think about plus, we think about minus, we think about and, we think about or, and stuff like that. Okay? Because they work on some value and then they return something, right? So now the question is, what is this operator doing then? As it turns out, in a comma expression, all it does is to return the value that is on the right hand side of the comma. That's all it does. And it is also, let me think about this, I think it is right associative. So that means as one single expression, okay, this is one huge long expression here, the value of this expression is the last portion. This is the actual value of that entire expression. It is just the last component. Now in this context, we don't care, right? I mean, the value of this entire expression is not used for controlling the loop. So it's not really useful in this case, but that is how the comma operator does. Okay, if I make an imply function, then we can keep the post increment. That is correct, because if implies is a function, then x and y will have to they have to be evaluated before they can be pushed as a okay, that's a CISP410 thing, but they have to be evaluated before they can become arguments to be passed to the function. But here's a question for Aiden. What if you're using C++ and you mention inline? Does inline function also guarantee the arguments are all evaluated? That's a question. You don't have to answer the question, but it's an interesting one to ask. Yeah, you would hope so. All right, so I'm just copying and pasting here. The only thing we need to change is from the and to or. There we go. All right. So now we have a different setup. Okay, we got P as the actual predicate. Okay, the actual thing that we want to know is, does X make this predicate true or not? Okay, the function f is actually just a filter. Okay, it's basically asking, are we even interested in this? Okay, that's what it's asking. Because if we are not interested, then it should not matter. Okay, so now we need to change the array a little bit. Okay, just to make it applicable. So what we want to do, because the filter is to say anything that is negative, we don't care, okay? So all of these negative things, we can keep them the same way that they are. But for the positive stuff, okay, we got a 2, we got a 5, a 10, and a 9. Okay, so let's change this to a 6, and we'll change that 9 to an 8. In other words, if you look at all the non-negative values in this universe, they're all even. But when you look at everything in this universe, they are not all even. Okay, -2 is even, but it's negative, and the -7 is negative, and it is not even. But when you look at everything that is non-negative, oh, I still got a 3 here, so we need to fix that. But when you look at everything that is non-negative, they're all even. So 4 is positive and even, 2 is positive and even, 6 is the same way, 10 is the same way, 8 is the same way. Okay. So now when we test the program, okay, we also need to pass the filter function, which is f. So we need to pass that one extra thing, and that's it. So we'll test it for all first. Okay, for all. Before I run the program, okay, what do you think should be the result the way it is set up? Should this for all return a true, or should this for all return a false? We got a filter. The filter says if something is not non-negative, we are not even interested. And then the predicate P is saying, well, I want to see if this thing that we're examining is even or not. So what should for all here on line 44 be returned? In other words, if we only look at the non-negative values in this universe, are they all even? That's basically what we are asking. And the answer is yes, they should be all even. So when we test run this program, the variable test should get a non-zero value. So we'll give it a try now. So we go to debug, and oh, okay, it's on line 26. All right. So I have problems matching parentheses. All right, so we are missing a close here. There we go. All right, so that means this one is also missing a close paren. All right, so let's try it again. All right. And then we just run the program to the breakpoint, but the breakpoint is not going to be here anymore. And we have to make the breakpoint all the way down here. All right, so according to my theory, test as a variable should be non-zero. Okay, we run it, and we take a look at test, and it is non-zero. Okay, so that's good. So if we change the for all to exist, you know it's going to be a 1 too, because if every non-negative integer is even, and then we turn around and ask, is there at least one of them being, is there at least one non-negative integer being even? Obviously the answer is going to be a 1. So we're going to change the array again. Okay, we'll say that, okay, let's only make one of the non-negative values being even. So we'll return this one back to a 3. I think this one was a 7. I could be wrong, but it doesn't matter. Okay, we'll just turn all of them except for 1 being both positive and even. And then we'll first test for all, okay, because this time it should return a false. So we debug, and then we run, and it does return a value of false. Okay, very good. And if we switch from a for all to a exists, this time it should return a true, because exists basically says if there's at least one value in this entire universe, it is non-negative and it is also even, then this function would return a non-zero value. So we'll go ahead and debug it. Take a look, run the program, and test is indeed returning a 1. So this is kind of a way for me to illustrate the concept of exists for all, and then the concept of filtering using an actual program in just plain C. This is the first time I actually do this, for CISP440. Not really sure whether it helps or makes things more confusing, or both. Okay, sometimes it can be both. So I'll let you guys let me know, either using a direct message or using the forum or the text channel, if you want to. But just another way to explain it. Oh, okay, that's cool. And I'm pretty sure someone is going to say, but can you copy and paste the program? Yes, that's why we use Discord, because I can use a quote in the text channel and just paste the entire program, and there we go. Oh, I need the quote to stop the entire thing. There we go. Isn't that nice? I mean, it even has syntax highlighting and stuff like that. That is why I like Discord. Okay, we got a few more people typing, and I'll see if I can answer those questions. If not, I got a few things to remind people. Yep, okay, now would be a good time to share this with the class. Alright, so I'm going to open up a few activities for you guys. The first one is set theory. The due date is already set to the next class right before the class on Wednesday. So you got 2 days to work on this, and then you have to be careful, because this one only let you turn it in once. So if you turn it in and you say, oh, I just made a mistake, there's no way to go back and fix it. Okay, so you got to be, just be careful, okay, before you turn it in. Once you start on this assignment, once you start on this activity, you have all the way up until basically noontime on Wednesday before you click submit. Okay, so there's no actual duration limitation or restrictions. You just have to turn it in before the due date. Okay, but once you turn it in, once you submit, you cannot resubmit. Now we will take a look at the row taking activity for today, which is going to be fun. Okay, so we'll go take a look. This one is due. It's due by the end of today's class period, so we got about 14 minutes to do this. So I got to show you what those words are. You mean the row taking activity? It is a quiz, but it's not released yet, because I want to show you the answer first. Oh, I thought I wrote the answers here, but it didn't take it. Okay, that's fine. We'll go ahead and. Okay, what is tax row taking word for the day? All right. So we'll make this. Oh, we need to make sure this is not multiple choice. Sometimes I use the default of multiple choice and becomes way too easy. So let's at least make this a little more fun. So it is exists or for all as one word. Okay, both will work. I'm taking both as correct answers. And then we'll say save and publish. You should be able, if you refresh your browser at this point, you should be able to see row taking 2021-0201. And once again, the words are for all as one word, all lowercase, or exists, all lowercase as one word. And you have another 12 minutes or so to do it. Uh-oh, it's blank. Why is it blank? Because I thought I specified a question. Oh, right. forgot to update. That's probably what I did last time too. Alright, fine, we'll delete it and then do again. Okay. Yes, I could have done it in a different way, but yeah, we'll go ahead and get rid of it. Because I can't change the question once it has started. You guys will be locked into the question that you saw. That's one thing about Canvas that is kind of weird. Okay, so we get to here. The group is row taking. And we'll say this is row of 2021 0201. But as I'm doing this, you guys can continue to think about the program that I just wrote, which is in Discord. So you might want to take a look at that program and see if you have any questions about that program, because it's supposed to illustrate the concept of the quantifiers as well as the filtering, based on the quantifiers. So that's what you can do when I'm working on this. Alright. And then I need to specify the time. Okay, so we'll still make it February 1st, 1:20 p.m. February 1st, 1:20 p.m. And make sure that this time I really got the question in. Alright, update question. There we go. And then save and publish. There we go. So if you refresh, that should be okay this time. Because let me preview it and see if it, yep, okay. There we go. Okay, so it should work for all of you. So I'm going to give you guys maybe 15 seconds, 20 seconds to get this done. And yes, now it does exist. All right. So I'm guessing most people are getting the row taking thing done. And I want to kind of go back to the module and see if you guys have any questions. You can basically test, you can play with that program, by the way, because you can change the predicate. You can just negate whatever is in the predicate, and then instead of using exist, use for all, because what I claim here, that should all work. So we got one question coming. I'm gonna answer the question, and then we move on to the next section. Okay. Yes, it is considered a quiz, but it's actually a homework. Because once you start it, you have all the way until Wednesday before noon to turn it in. So it's not really a quiz, but I like to use a quiz because it can grade a few of the items automatically. All right. All right. Yes, you can. So Anita is correct. You can start and think about it, read some more, try out, the various things, and then come back and finish it. Yes. So you have you have a lot of time to do it. Basically, you have close to 2 days to do it. So the last portion of section 4 is really a notation kind of thing. So instead of using this notation where we say for all E is an element of X implies, the negation of P of E is true. So instead of doing it like this, I just kind of shorthand it to for all e in x, the negation of p of e is true. So it's really just moving, the element of, expression, moving it all the way next to for all, so that I don't need to, it's just an easier way to express the same thing. It saves me one e in this case. So that's the only portion of section 4 that I need to go over before we kind of go back to how do we use quantifiers to express set operations. So that's going to be the next topic here. Set theory using quantifiers. So let me take a look at the time. We got 7 minutes or 6 minutes or so. So that's kind of plenty of time. So we'll go ahead and get started with this one. And it has not been refreshed yet. Let me go ahead and refresh that. So this way, the whole idea of me refreshing everything, now it is refreshed, is so that you guys can right click on something like this and understand how it is typed in LaTeX. Okay, so that's the only change. The content is the same as before. All right, so we are now in module 0288. And then the first part is, how do we know whether two items are the same or not? How do we define equality, especially if there are, each one is a set, okay? So the first thing is, if one is a set and the other one is not, then x equals y is false. That's kind of easy to understand because, that means, they are not even of the same type, okay? Things not of the same type cannot be the same. So given that x and y are not sets, then we use the normal comparison operator. Okay, so we look at the value of x, we look at the value of y, and see if they have the same values. Given that x and y are both sets, then we'll use the following. We say that x equals to y if and only if, okay, and what is to the right hand side of the if and only if is for all e in x, e is also in y, and for all e in y, e is also in x. That kind of makes sense, right? And there's a more concise way to say that is x equals to y if x is a set and y is also a set, then x equals y if and only if for all e, e is in x, if and only if x, e is in y. So these two statements are the same. This one here and this one here, they are really saying exactly the same thing. One is a little bit more concise and the other one is less concise. So do we have any questions about this portion? How we define equality between two sets, basically. All right. So now we take a look at how we describe the membership of a set. So before we had quantifiers, we kind of used this notation to basically say E is a set, okay, because we have the curly braces here to indicate it is a set, and then we use X here to basically look at any member inside this particular set. And then the vertical bar says, such that, okay, if we have a member X, then P of X is true in order to be a member of the set E. So, but when we switch to the quantifier notation, then it becomes like this. It basically says, for everything in the entire universe, okay, X is in the set E if and only if P of X is true. So it's about the same as what we had before, because what we had before is really just X is in E if and only if P of X is true. But now we just put a universal quantifier on top of the entire thing. So basically all it is saying is, before, when we did not use quantifier, a lot of times the universal quantifier is implied And now we can spell it out because we have already talked about the universal quantifier as well as the existential quantifier. So section 5 talks about the empty set. Now, how do we know that a set S is empty? Well, if it is not the case that there's at least one thing in the entire universe, and that thing is an element of S, if this entire expression is true, that means S is an empty set. There's nothing in it. Okay, so it's kind of just sort of playing with words, but at the same time, it is a different way of understanding, the concept of an empty set. It is also a way for us to exercise the concept of the quantifiers. Section 6 talks about the intersection and the union. So before, we just have whatever is in here, but without the quantifier. We just stick a quantifier, on the outside, and now it is quantified. But really, it's the same thing. Okay, it's just that we have a quantifier on the outside. The Cartesian product is a little bit more interesting because we bind x to the set A, we bind y to the set B, and then we basically say x, y should be in the Cartesian product of A and B. So this portion is one condition, and then we have a conjunction here to basically say if we find anything in the set of A Cartesian product with B, then the first component of the two tuple should be in A, and then the second item from the two tuples should be from B. So the question is, do you think this conjunction is even needed? In other words, if I don't have this conjunction here and forget about the right-hand side of the conjunction, are we still defining Cartesian products correctly? That is the question. So to answer this question, let me give you an example. So let me turn on the tablet, and I'm just looking at the time. Darn it, it's out of time. So we are running out of time, and the question is for number 7, for section 7, if I do not have this conjunction and the other portion of the definition, is it still a correct definition of the Cartesian product? That is the question. And you can look at this as an ungraded assignment because I want you guys to think about this. And then on Wednesday, what I'll do is I will basically give you an example of something that is not a Cartesian product, but it looks like it is a Cartesian product. At least it will follow just this part of the condition. It will make this part of the conjunction true, but it is not an actual Cartesian product. So I want you guys to think about that, okay? Because it basically is saying, why do we have a conjunction of something that seems to be saying exactly the same thing? So we'll talk about that. Any questions before we end today's lecture? Alright, I'm not seeing anything. So I will go ahead and stop the screen sharing. So you got a few things to do. One is the quote-unquote homework assignment, which is in the form of a quiz on Canvas. So get it done before, turn it in, okay? Make sure you submit it before noon on Wednesday. And then the second one is an ungraded assignment about Cartesian product. I want you to define a set, okay, that claims to be the Cartesian product between a set A and a set B, but that particular set, even though it meets the first requirement of the conjunction, it really is not a Cartesian product of the set A and the set B. Okay, so that's what I want you guys to think about. It is not going to be graded, but I want you to think about it. Alright, so we are out of time today. I will see you guys on Wednesday. But I will stay online for another maybe 5 minutes or so, just in case some people have questions about the material today. So there we go. I'm gonna stop my